That would be after, we're doing circuits right now, or electrodynamics, then we will get into magnetism, so then we get to Teslas. All right, enough of the trivia. So we have this relationship there between current, voltage, and resistance. So let's take so if we think about resistors, the resistance is just this number here, which is material specific. You look it up, resistivity of copper, you look it up, it'll give you several different answers if you look at enough places, times the length of the wire over the cross-sectional area. Which is why in the lab, we had a value for copper. All right. We assumed that the area was constant of the wire, at least for part B, and then you measured the resistance for different lengths. And it should be a linear relationship. Then you chose a different area, went through the same exercise, and said there should be a proper ratio there. So if I take a wire that is yay long, it will have a certain automatic resistance to it. If I double the length, I double the resistance. So in order to create a resistor, what you do is you can take incredibly skinny wire, so it was drop point cross-sectional area, take an incredibly long wire, and I create a resistor. And if you look at a resistor, the typical ones that if you went to, let's assume Radio Shack still exists. If you went to Radio Shack, their resistors are about yay big, yay long, about that thick, with colors on them. It's just a lot of skinny wire wrapped up, insulated and wrapped up. And so the symbol for a resistor sort of represents that you take a lot of wire and you cram it into a small space. That's the symbol for a resistor. So if I just took a simple circuit, battery and resistor, I have a power supply here, connected to a resistor. Let's say it's a 12-volt battery and a 3-ohm resistor. Then what's going to happen is, if I gain 12 volts here, I have to lose 12 volts here in order to get back to zero. Similar to it is Kirchhoff's voltage loop rule. We did that with the capacitor. So whatever I gain, I have to lose in order to get back to zero when I get back to where I started. So if I'm going to lose 12 volts going across that way, and my resistance is 3 ohms, then my current, 4 amperes. Just using Ohm's law. I have 12 is equal to 3 pi. That's delta V is equal to 1. And apparently that's where we're leaving.
Is it possible to not get back what you gained and like have something happen that's bad?
Oh, where it's not zero here?
Yeah.
And you get back to it? You have to be introducing some non-conservative forces.
Is that how electronics break sometimes? Stuff like that?
Well, basically, as you run a current through it, the wire's going to heat up, and at some point, you're going to, I guess, with enough current, it's going to melt. Or somehow, yeah, in essence, melts, or somehow you got so much charge that melting is the way I've seen it in the past, and so then it breaks. Or you have a circuit breaker in there so that if current ever exceeds a certain amount, it automatically trips.
How does a taser work in terms of how it?
You basically build up, you have a positive and negative plate. You build up a charge on it, and then it's looking for some way of the current negative charges, the electrons want to jump over the positive plate, or current wants to float the other way, and then you give it a conduit.
Oh, so the two like probes being like the plates,
Yeah.
and it's shot at the body is used as the conduit.
Yeah.
So just
So it's like a capacitor inside the taser, and then
Yeah.
one plate is connected to one probe, and the other plate is connected to the other one.
Yep. And there are videos out there of how to take one of the disposable cameras and convert that into one. And then some testing on various people who don't mind showing on YouTube that they don't mind being tested. Flashing back to the guy who jumped in the cactus. Said I was gonna do it, so I had to do it. Yeah, but you didn't have to say you were gonna do it. I don't know if you've seen that, it's probably 10 years old at this point.
Are there any Radio Shacks that exist?
I think there is one in Winston-Salem still, but it could have gone under, I know that one closed. But I was thinking there's one in northwestern part down.
I didn't know if any exist in the entire country or not anymore.
They do have an online business, I know that.
Yeah.
As far as brick and mortar
You wanna
There's
pause
one
it?
Blockbuster left still.
in Oregon,
Yeah,
Washington?
in Oregon, I think. Yeah.
Pause it.
Yeah, or stop it.